Hello, everyone. Good afternoon. Appreciate you being here. I know it's late in the day, and these days can be kind of mentally exhausting, so we appreciate you sticking around for this. Good afternoon. I'm Scott Gordon. I'm here with Matthias Moser. We're from 8451. Matthias kind of laughed at me when I put this slide together because he noticed I pulled the photos off of our employee intranet. These are our employee photos from like 10 years ago, I think. So he said they're going to think the dads showed up to do the presentation instead of the kids. So I guess if we get invited back next year, we'll probably need to update those. But anyway, so I'm a data engineer at 8451. Matthias, you want?
I'm a data engineer and data architect at 8451.
Okay, great. A little bit about our company. So 8451 is the market research, data science, and media marketing division of the nationwide grocery retailer, the Kroger Company. We capture and analyze over 8 million in-store and digital grocery sales transactions each day, along with digital shopping behavior across all the outlets in Kroger's ecosystem. So that includes stores like Kroger, Fred Meyer, Ralph's, Harris Teeter, Smith's, Fry's, King Soopers, Mariano's, and several other smaller banners as well. Today we're gonna be talking about change data feed in a streaming data flow. We have two different examples to show you. First of all, what it looks like coming from a streaming source system, and then secondly, we'll show what it looks like when the change data is coming from a Delta Lake table. So there you go, Matthias.
Perfect. So I will start talking about change data capture from a streaming source and illustrate that with an example from our work. So what is change data capture? Here's a definition. Change data capture is the process of recognizing when data has changed in the source system so that a downstream system can take an action based on that change. And in the most typical use case, our source system is a database, relational database, and the changes that can happen on the source systems are new records can be inserted, existing records can be updated, or existing records can be deleted. And that's what I want to work with. Our specific example is Kroger online orders. If you go to Kroger.com or any of the other banners, then if you place orders, these orders are stored in a database. When you create an order, or when you start an order, an order entry is created. When you make changes, like you add an item, then these orders are updated. And in some cases, an order is deleted. And that's the example that I want to go through. We'll greatly simplify that, but that's the example to work with. So one more time, on the left-hand side, I have Kroger.com, the website, and it updates orders in my orders database or an orders table in the database. And what we want to do is we want to analyze this data in Databricks. So the question is, how do I get the data from my operational relational database into Databricks? And we want to do this in near real time. So the question is, how do I do this best? And this is where change data capture comes in. So on the orders database on the left-hand side, I have to enable change data capture. Works differently in different systems, but the general concept is always the same. It captures every change on my table. And you see 5 records here as a simple example. The first 2 records here are inserts. So a new order was created and was inserted in the orders table. And you see order ID, customer ID, status, and items. Those are that's a simplified representation of my order. And then I have a timestamp and an operation that's not the actual data in the database, but that's data for the changes. So at a specific time, an insert happened, or further down, you see 2 updates. You see highlighted what changed. In one case, the status changed. In another case, an item was added. And then you see an example for a delete. So order with order ID 1620 was deleted in this example. Good. So what do I do with this change data? In the typical use cases that some of you probably are familiar with, the change data is pushed onto a streaming system. In our case, we work in Azure. We use Event Hub for that. Other systems that you might be using are Kafka or GCP PubSub or in AWS Kinesis. And on the right-hand side, I want to take that stream from the streaming system and persist it in my analytical database, so in Databricks in our case. All the way to the right, you have the orders database in Databricks that represents a replica of what I have in the operational database. And on the way there, I have a bronze table that captures all the changes. I'll go into this in more detail on the next slides. Before that, here is just one example event as it comes from the streaming system. Typically, we get this in JSON, and you see this was one of the inserts. You see the timestamp and the operation, then the data for the order. And then these streaming systems like Event Hub or Kafka, they send additional metadata. This came on a specific topic. There's another timestamp. That's now the timestamp when the data was pushed onto the streaming system. And there might be additional streaming metadata that you get with the data that you receive. Here's what this looks like specifically implemented in DLT. And I learned earlier that DLT will no longer be called DLT. I think it's now Lake Flow Declarative Pipelines, but I will continue to say DLT until I get used to the new naming. Good, so one more time on the left-hand side, the orders database fed from Kroger.com, and then on the right-hand side, I have a bronze table to the left, and then I have a silver table, and that silver table should represent what I have in the operational system that backs our website. And in between, I have a few that I use for any transformations that I want to apply. To store in the orders table the data as raw as possible, so I have everything. I have all the data that I've ever received, and transformations I can apply on this using this orders bronze view. Good. Here's the definition of the orders bronze table. I have to look here. This is a little small. So what happens here? I define the table. Then this reads from a stream, read stream format Kafka. You might ask, why is this Kafka? When I earlier said we're using Event Hubs. Event Hubs implements an interface, implements the Kafka interface, so we can use that. At some point, DLT might support Event Hubs natively, and we could maybe do a read stream format Event Hubs. I have to pass options in, authentication, the location or the address of the Azure Event Hub servers, and then I load that data, and what I do here is the value that we earlier saw in JSON actually comes in as a binary value, so I cast it as a string, and then the last statement here converts this to, or converts it to a value column that has the actual schema applied. Get order schema, the function here, imagine, gets the schema that's defined elsewhere. Good. Second step in my DLT pipeline is the order bronze view. Very simple example here. In practice, we will probably do more here, but it just selects value.star. So it breaks out that one value column into multiple columns, the attributes in that JSON value that you saw earlier. And finally, here's my silvers table, So, and here's where the DLT magic happens. So now we need to take all these changes and we need to apply those changes in our Delta table. And I could do this with a merge statement. If you just heard the other change data capture talk in room 2005, an hour ago, they talked about that it might feel simple to implement this with a merge statement, but there's a lot of details that you need to take care of. So it's very convenient to just be able to use apply changes and not have to worry about all these details. What does apply changes do? The source for my apply changes is the bronze field. The target is the silvers table. I need to provide a primary key, that's my order ID. And apply changes will then automatically use this order ID to see whether it needs to apply an insert or an update. So I don't need to tell apply changes that. If the order ID already exists, then it will apply an update. If it's a new order ID, then it'll do an insert. I need to tell apply changes how to sequence my records. Records might, on a streaming system, not always arrive in order. So I use the timestamp that comes from the original database, because I know that's how the changes happened on the original database. That should be a reliable value to sequence my changes by. I have deletes. Apply changes has this parameter apply as deletes. And if the operation is a delete, then I tell it that it should apply deletes on that. And then finally, I use the parameter store as SCD type 1 to say simply apply the changes as they come along in my target table. Apply changes also supports SCD type 2, so you automatically get an SCD type 2 table if you want to, that captures all the changes or preserves all the changes for you. So you could look at what did your data look like yesterday, last week, a month ago. Good. With that, a few considerations for when you use apply changes. It does use merge under the hood. Again, here's a reference to Ray's presentation, Mastering Change Data Capture with DLT, if you wanted to look at that video once it's provided. He talks about that what's under the hood isn't a simple merge statement, but it's probably a couple thousand lines of code that deals with all sorts of edge cases that you could run into. What you need to make sure is you need to provide a well-defined primary key, really simple in our case with our orders. And for performance, you have to make sure that that order ID can be looked up quickly. So either use partitions or Z ordering, or use liquid clustering if you're already using that. In our cases, a lot of our data is still partitioned and Z ordered. Good. You need a reliable sequence by column, so timestamp or some numeric sequence value that comes from the original database. And then you can use expectations, DLT expectations, to manage any type of unexpected records or bad data. In my very simple example, I'm just assuming the data looks the way it should. And that's really all on a very simple CDC use case. And Scott will talk about what this looks like if you work completely in Databricks.
Okay, thank you, Matthias. So now we're going to take a look at what change data looks like when it comes through a Delta Lake table, rather than through a kind of a general change data capture interface. The example, the flow of the data is going to be pretty similar to what Matthias just described, but there's some differences in the way change data looks in a Delta Lake table. So we'll get into those details. So for continuity of this presentation, I'm going to build off of the silver table that Matthias populated with order update activity. We're going to build a DLT pipeline that creates an order status table by consuming update activity from order silver. And for this data flow, I'd like to use a streaming read because I don't want to read the entirety of the order silver table every time my pipeline runs. I want to just process new activity with each run of the pipeline. And in addition to that, I know that the order silver table, along with inserts, is going to likely have updates and potentially maybe even deletes as well. So I need to handle that. So a little bit of context about reading a Delta Lake table using Spark. So when you read a Delta Lake table using a Spark read, it's just like saying select star from the table. You get the entire contents of the table with all the rows in their your current image as of the time of the read. When you do a read stream on a Delta Lake table, it's like saying select star from the table where data is newer than my last read stream. So read stream automatically keeps a checkpoint. Upon successful read of the table, it checkpoints where you were at in the Delta log when you completed that read. So that next time you call read stream, it can go to that checkpoint and say, okay, what activity is new since that read? That checkpoint is part of Spark structured streaming. It's completely maintained for you. It's invisible. You don't code anything. You don't see it. DLT will pick the location of the checkpoint and maintain it for you on your own. So you think about using read stream on the original source, like Matthias talked about, using Kafka or Event Hubs, a traditional streaming platform. Reasoning what read stream is doing is pretty straightforward, right? It's just going to the topic and requesting new events from the topic, right? So you get each event once and only once. And in traditional streaming data flows, they were referred to as append-only data flows because that was the most common use case. You're always receiving new events in, and you simply append those as records to your target table, always appending. When you think about reading a Delta Lake table, well, now you're reading, a table, a static set of data. Well, that data could have gotten there via inserts, or records could have been updated, or records could have even been deleted. Well, your basic read stream, this append-only flow, doesn't handle that. As a matter of fact, if you were to call read stream, just as the code is here, on a Delta Lake table that had updates on it, you're going to get an error. Read stream is just going to come back and say, no, I see updates. I don't know what to do with those. So there is an option you can throw in there to get around that. There's the skip change commits. So if you add that option, as you're reading through the table, it will read the inserts. When it sees an update or delete, it'll simply just skip that activity in the log and go on looking for more inserts. Okay, you've suppressed the error, great, but you see the what's missing here, right? Now your downstream table is not up to date with the upstream because you chose to ignore those updates. So technically it works, but probably not the output you're really looking for. So now, better together. We get to the title of this presentation and what inspired us to put this together. In the first place, by combining a read stream on a table with this option read change feed, now you have a mechanism, an interface for which you can consume not only new inserts, but you can successfully consume and process updates and deletes from that source table as well. Now, in order to be able to do that, to use the read change feed option, the table you're reading from has to have change feed enabled on it. So when Matthias built his silver table for me, he turned on this feature, enable change feed, set that to true. What happens when you set that on a table is, if you picture what a Delta Lake table looks like in storage, it's a folder with a bunch of Parquet files, a subdirectory with the Delta log, and the Delta log tells you which Parquet files are part of which version of the table. Well, when you enable change feed, you get another subdirectory, and your change information is written there. So it lives alongside the table data as part of that table, but separate from the actual table data itself. Okay, so back to our pipeline. No, I'm sorry, let's look at an example of some change data first. So this is what it looks like when you call that read change feed. You see there's 3 metadata columns that come through in the data, underscore change type, underscore commit version, underscore commit timestamp, and then along with all of the other attributes for each row of data. You'll see inserts, updates, deletes, and specific to Delta Lake change feed format. In the case of an update, you'll see 2 rows. You'll see the pre-image, which is what that row looked like before it was updated, and the post-image, which is what that row looked like after it was updated. This is a little different format than some other change data feed patterns, like what Matthias was showing. Some systems will just simply show you what changed. So they'll only show the attribute that had a change and not the rest of the row. It gets a little complicated to deal with. Again, if you were in this session before ours, which if you weren't, I encourage you to go look at it online. Ray talked about, so how do you handle it when all you know is what the one column that changed and all the other columns are effectively null? Well, you don't want to, null things out, right? You just want to apply the change. So that logic gets very complicated. Apply changes does handle that, but when they crafted change data for Delta Lake, I guess knowing how complicated that is, they said, hey, let's just present the entire row, right? So I don't have to worry about which attributes changed and which didn't. I just know, oh, this is the current image of the row, and that's what I'll apply. I have some more detailed examples I'll show you. So again, back to our pipeline we're building. We're simply going to read from that silver table using the read change feed option, and then we're going to apply those changes into an order status table. So what that code looks like when I'm reading, I'm going to just declare a DLT view. It's going to do a read stream on the order silver table, and as I showed you previously, use this read change feed option. I'm also going to take a couple of the metadata columns and rename them. I want to actually capture the change type and the commit timestamp into my order status table so I can see what those look like when they came through the data. I don't want to persist them with the names underscore change type and underscore commit timestamp, because those columns are reserved specifically for Delta Lake change data capture. So simply rename them and I can capture the data into my target table. So here's what, in this example we've been showing you, here's what it looks like coming through change data feed. Again, I've renamed the change type and commit timestamp so I can keep them in my data and store them. So we had order 2001 was inserted, order 2002 was inserted as well, order 1784 was updated. Again, you'll see the pre-image and the post-image, and we can see the status changed from open to ship. However, again, we do get the entire row here. I'm only showing you a few attributes, but I get that entire row of data as it looked like after it was updated. Order 2002 that was previously inserted got an update a few seconds later. You can see the items array was changed, and third item was added. And then order 1620 was deleted. And again, a key thing here is in that delete activity, I still see the entire row. So I see it, what it looked like at the point where it was deleted. Okay, so now here's the write to order status. I'm going to use apply changes, as Matthias already described to you. It basically works like what we commonly call an upsert, right? It's going to conditionally either insert or update, depending on if that key is in the table or not. So there's actually 4 things apply changes can do. When it sees an incoming row, it looks at the target table, and there's 4 outcomes of that. It can choose to insert that row into the target table. It can choose to update the corresponding row in the target table. It can optionally decide to delete the row, and that would be if you're using this apply as deletes option and the row meets the delete condition, then it could delete it. There's actually a 4th option it can do. It can actually decide to ignore that row and just drop it and not apply an update. Well, when would it do that? Well, that's to handle that case of changes coming out of order. So as soon as it sees that order ID is in the table, that becomes a candidate for an update. But then the next thing it's going to do is evaluate the sequence. And it's going to say, is the sequence of the incoming row newer than what's already in the table? And if it is, then the update is applied. If it's not newer, that's the condition where it'll just reject that row, just drop it, ignore it. And that's just that guarantee to make sure that the output of apply changes is always the latest data, the latest, most accurate version of that record, and it's never going to update newer data with an older value. Now in Delta table change data feed, it won't come through out of order. That interface is written where it will deliver to you the changes in the proper chronological order. but nevertheless, the sequence by is there, for use in other cases where, like if your upstream was a, Kafka or a streaming platform, since you're not the producer of the data, you can't guarantee that producer doesn't sometimes accidentally put things into the stream out of order. So the sequence by will protect you there. Okay, so this is what order status looks like after this first run of data comes through it. So you see order 2001 was inserted. I captured the change type there. 1784 had an update. So our results are that post image of the row where we see the status which is now shipped. Order 2002, if you remember, it had an insert followed by an update. So again, the output of apply changes is we have that final image of the row that is the third item was added. And that's where the benefit of the change data having that entire row is beneficial, right? Because all I need to know is the final update post image. And that tells me the current state of the record. I don't need to know that, oh, items changed, but status didn't, right? All I need to know is what's the current latest version of this row, and that's what gets applied. And then order, which one did we delete? 1620 is not in the table. That's because we told it to apply. I'll back up to that code a little bit. We had the apply as deletes. So is that showing? Yeah. Apply as deletes was the action, and it met that condition. The source change type equaled the word delete, so that's what caused that one to get deleted. So the deleting of the data is actually optional, though. That's you don't have to include that apply as deletes option. So in this version of the code, I just simply took out apply as deletes. That's all I took out. So I said there's 4 outcomes of apply changes. Well, if I remove delete as an option, now there's only 3 outcomes that can happen: an insert, an update, or ignore. So what do you think it does with that delete, that record that came through change data saying it was a delete? Is it going to ignore it? Who thinks it'll ignore it? Good. All right, so that it's not going to ignore it. So that leaves insert or update, right? Well, following the rules, it's going to look and see, is that order ID already in the target table? Yes, it is. So it's a candidate for an update. Is the sequence of the delete newer than what's in my target table? Well, yes, it is, because I have, the version I have is whatever came through previously before it was deleted. So it meets that condition for a delete. It is newer information than what I have in my table. So in that case, that record's actually updated. And because I'm capturing the change type, that gets updated to the word delete. I have the new timestamp showing when it was deleted. And again, I have that image of the row of exactly what it looked like at the time of delete. Now, obviously, whether or not you want to apply deletes or keep them is up to you, right? It's a business use case, not a technical decision. But if you just decide to keep them, sometimes people refer to this as kind of a soft delete. I don't know if you agree with that or disagree. But regardless, I've retained the record in my table, but I still have a change column that tells me, oh, this was deleted from the upstream, so I can differentiate it. Okay, so in summary, using change data from a Delta Lake table, first of all, you have to enable change data feed on that table. That can be enabled when the table's created. Like if it's created in DLT, you can just add it as a table property in the pipeline it's creating. But it doesn't have to be. You can add change data. You can enable change data feed to a table at any time. So it's not a feature you'd want to turn on in case you want to use it someday, right? Because there is some overhead with tracking that change data with every update to the table. So you can wait until one of your consumers says, hey, I'd like to consume changes from your table. Okay, you can enable it at that time. And you can also disable it at any time. Then, once you have change data enabled, to read it, you'll read with this read change feed option. Now that is optional, right? The change data sits alongside the table data, so it's still a valid Delta Lake table. You can still read it, query it, select star from it, You don't have to consume the change data, but once it's enabled, then you have that option of reading the change data if you want. And then generally, you don't have to, but generally you'll use apply changes on the target then that's kind of the right side of the changes to apply the changes into the target table as you see fit. There's some references, other presentations by 8451 this week, which you already missed, but you look them up online, I guess.